Okay, good morning everyone, and welcome to our session. Views of repository webhooks to access hundreds of internal CI systems. Let's present ourselves. So my name is Omer. I have a background of around 15 years in multiple security disciplines, both offensive and defensive, like hacking to web applications and cloud environments. Until a few months ago, I led the security research for a startup named Cybersecurity. We have a product that is focused on securing software delivery pipelines, and it was acquired by Palo Alto Networks a few months ago. So today I lead the application security research for the Prisma cloud platform by Palo Alto Networks.
My name is Asaf Greenholts. I have about 7 years of experience in cybersecurity. I've done incident response, SOC, security architecture, and for the last 3 years I've been doing application security, which 2 out of them I've been working for cybersecurity, and now for Palo Alto as a security researcher, basically researching CI/CD security.
Okay, besides the product that we're highly focused on our day-to-day basis, we try to contribute and work with the InfoSec and dev communities to contribute in any way we can. 2 examples for that. One of them is the OWASP Top 10 CI/CD Security Risks Initiative. We saw that defenders lack knowledge and methodologies of how to protect their CI/CD ecosystem and what risks they should be focused on. So this project aims to assist us all in focusing on what matters. It's the result of an extensive research that we've done for many months, and it's backed up by the community. So we welcome you all we encourage you all to read it. Besides that, another project that we are proud of is the CI/CD GOAT. That's an open source, deliberately vulnerable CI/CD environment with 11 different hacking challenges based on the top 10 risks. It allows everyone, it gives everyone the chance to practice on hacking and defending CI/CD environments. You can Google it, download it, give it a try, maybe even contribute. It's pretty fun. So after all that intro, let's start.
Okay, guys, so let's start thinking like attackers. So what do attackers want? Attackers want money. Attackers want to cause destruction. Attackers want to steal sensitive data, right? Well, I'm as an attacker, I have a lifelong goal of going to Hawaii. How do I achieve that goal? One way to achieve that goal is to attack cloud environments. Well, we've seen in the past years attacks on major companies. We've seen attackers targeting their cloud environments. We've seen Uber, hackers exposed 57 million users' data through public S3 bucket. We've seen Tesla's infrastructure used to mine cryptocurrency. And we've seen Capital One pay a small fine of $80 million due to their cloud data breach. However, in the last few years, we've seen the attack surface evolving, and we've seen more and more attacks against the software delivery process in order to compromise the same cloud environments. So here are some examples from the last year. We can see that LastPass dev environment was hacked, leading to a data leak. We've seen 130 Dropbox GitHub repositories compromised in a successful phishing attack, and Toyota that disclosed a data leak after a key was exposed on their GitHub repositories. So we have those software delivery processes, and one major part of that process is the build system, often called the CI system or CI/CD system. This system basically is responsible for testing the code, building the code, maybe sometimes shipping the code to environments. So it's a really sensitive system that companies want to protect. One of the security measures that companies take to protect those systems is to put them behind a corporate firewall, right? To limit the access of external, let's say, attackers targeting those systems. They're using some kind of, let's say, AWS security groups or some kind of network restriction. So let's try to fill the crowd a little bit. How many of you work for an organization, by raise of hand, that has an internal CI? Okay, we see about most of you hasn't used internal CI. Well, so if my organization has an internal CI, am I really secure? Well, we're not so sure. Today we'll show you a novel attack method that we found to attack those internal CI systems, which basically anyone can do. Hope you'll have fun.
Okay, so let's begin our journey and see how we could abuse repository webhooks to access these internal CI systems. So as Asaf just mentioned, many organizations today, they opt for an architecture that combines a SaaS-based source control management system, SCM, like GitHub or GitLab with a self-managed CI, like TeamCity or Jenkins, located behind the corporate's firewalls, which is not exposed to the public internet. And lots of the organizations using such architectures, they allow these internal CI systems to receive webhook events from the SaaS-based SCM, usually for the simple purpose of triggering pipelines. Now, to allow this communication, these organizations, the SCM vendors, they provide IP ranges for their webhook service that are whitelisted in the corporate firewall, which allows this communication to work. Now, here on the left, you can see how a webhook request is, how a webhook is configured on GitHub. You can only set the URL and modify some parameters, not much that you can do. Now on the right, you can see how a simple webhook request looks like. It's an HTTP post request where you can only set the contents of some fields, but you can't really affect the JSON schema, which is pre-configured by GitHub. Okay, so let's think if this architecture can risk the internal CI, as we already know that compromising the CI might lead the attackers straight to production or to the cloud. We have this architecture that you see here combining a SaaS-based GitHub account organization and an internal CI, Jenkins in this example. The webhook request is just an HTTP post request again. We can't modify its body, but only the URL. Question is it harmful? So one thing the attackers can try and do is to try and trigger pipelines. They can create their own GitHub organization and send a webhook event towards the victim CI, internal CI, with the hope of triggering pipeline jobs. Maybe that would create something interesting. Now, it is possible because the IP range provided by the SaaS SCM vendor, this IP range is shared between all of the different organizations in GitHub in this example. So I, as an attacker, can just create my own organization, send a webhook request towards the internal CI, and I will reach them network-wise. It might be not so easy to execute this attack of triggering pipeline jobs because first, usually the pipeline is bound with a specific repository, so it won't be possible to trigger pipelines by a foreign repository. And also, if they are not bound, the pipeline and the repository, GitHub, Jenkins, and other vendors, they allow to set a shared secret between them, so that will prevent this from working. So to sum it up, triggering pipeline, that's basically the main known risk today around webhooks in these architectures, and it can be easily addressed. So it seems like this architecture is kind of secure. And we wanted to challenge this assumption. We asked ourselves, why should attackers trying to abuse internal CI, internal Jenkins in this example, limit themselves just to triggering pipelines? I mean, while the port in the firewall was open to allow this communication with the purpose of triggering pipelines, it doesn't mean that the webhook request cannot be directed towards other CI endpoints besides the one that regularly listen to webhook events. For example, we can direct our webhooks to other endpoints, as you can see here, trying to retrieve valuable data like users, pipelines, logs of pipeline jobs, and if you are lucky enough to fall on an instance that grants unauthenticated admin privileges to unauthenticated users, and yeah, we see it happens quite a lot, we can maybe access some more sensitive areas in the CI, like the configurations and credential sections. So it sounds like a very interesting direction, but we have some major limitations here. I mean, I just showed you that when attackers or anyone creates webhook in GitHub, they are pretty limited. They don't have much flexibility in the configuration of the webhook. So though they have some major limitations there, let's start seeing what these are. Now, most systems, including CI system and Jenkins as well, they only accept HTTP GET request when users want to retrieve data from the system, and HTTP POST request when they want to actually make actions in the system. And our first challenge as attackers is that we cannot send HTTP GET requests from the webhook. So how would we be able to exfiltrate data from the CI? Second, if we do want to send a post request to make actual actions in the system, we have limitations that we cannot control the body of the request, which is how we instruct the server what to actually do. If you remember, these webhooks sent a pre-structured JSON. We can only affect some of its fields, not more than that, so we are pretty limited there. And also, Jenkins expects to receive a CSRF token when you send post requests, cross-site request forgery, and we don't have these tokens. So there's three major blockers that you see here that currently prevent us from accessing interesting endpoints in the CI, but hackers are like, yeah, so what? We can bypass this, and let's see how we can do that. So there's a bunch of things that we can do to bypass these restrictions, and one option is to abuse the Jenkins login mechanism. And the reason we choose to start with the Jenkins login mechanism is first because it's sensitive. Obviously, if we succeed there, we are inside the system. But also, it helps us to deal with these challenges that you see in the slide. First, it expects to receive post requests. And also, it's the only endpoint in Jenkins that expects a post request but doesn't require a CSRF token. So we overcame two of the three challenges that we have in front of us, but we still need to be able to control the body of the post request. Question is if we can do that. Let's see. So a Jenkins login request, it looks as follows. It is sent as an HTTP post request. And you can see that the credentials are sent in the body of the request, pretty standard to a login request. You can see the username and password in the body of the request. But lucky us, the Jenkins login accepts this, sending the credentials as query parameters, which is pretty nice because we can control the URL in the webhook that we send. Now, it's worth mentioning that this behavior was fixed in newer versions of Jenkins, but we analyzed the public statistics of Jenkins instances, which is available to everyone to consume, and we can tell you that there is a high percentage of instances around the world still using versions vulnerable to this behavior. So what we can do about it? What we can do now is to create a new webhook in GitHub and set the webhook URL as the Jenkins login request. Now we trigger the webhook, and if the login attempt fails with the credentials that we guess, we see this in the webhook event log. We are redirected to the Jenkins login error page. This is how we can identify that the credentials that we tried were not correct. But if the login is successful, we are redirected to the main Jenkins page, and you can see at the bottom that a valid session cookie is set. And that's awesome, right? Because now we can send webhook requests towards the internal CI. We can guess users' credentials and to get their valid session cookies. I can start smelling the waves of Hawaii. Okay, so obviously, if you want to use this entire flow to start brute forcing users' credentials, Jenkins credentials, we can do it manually. It would take us like thousands of years, and we have a flight to catch to Hawaii, so we don't have all the time. So we'd like to automate this process. We can create an automation using the GitHub API and start brute forcing the user's credentials until we inspect the response in the GitHub webhook event log until we find the correct credentials. And then we have valid credentials in our hands and a valid session cookie. Now, in lots of cases, Jenkins users are managed using are based on the Jenkins user database, which is the default authentication mechanism in Jenkins. So it lacks some basic security features like requiring strong passwords and some brute force, protecting against brute force attacks. So this is why this is all possible in many Jenkins instances around the world. This is how the request we were looking for looks like. That's an HTTP post request that can reach the internal CI, the internal Jenkins, sent to the login endpoint of Jenkins with a valid username and password attached as query parameters in the URL. And Jenkins returns a valid session cookie and an HTTP 302 redirection response. Amazing. There is a problem though, because GitHub won't follow this redirection. So, to sum it up, we can brute force Jenkins credentials, that's good, but we can't do much with it. Now, we can only send one stateless request each time through the webhook, but GitHub won't follow the redirection, and we can't send a webhook and just attach the cookie that we obtained, because we can't add or modify any headers in this webhook. So seems like we are kind of stuck now. So just for that, we have GitLab to the rescue.
Okay, so let's try a different scenario. In this scenario, same thing goes, but the organization uses GitLab and Jenkins. So we want to attack this internal Jenkins. Let's try to do the same thing and see what happens. So we're sending a login request like we did before, and we're getting back 302 with a redirection, with the cookie attached, same as before. The surprising thing is that what happens next. So GitLab follows the redirection. It sends a GET request. So instead of sending a POST request like Webhook services usually send, GitLab actually follows with a GET request and the cookie attached to the request itself. And what happens next is the exciting part, of course. Jenkins returns back the homepage of that specific user. Here you can see an example. This is a screenshot of the GitLab Webhook page. We send the same request that you've seen, and you can see on the bottom the HTML response of the page, and you can see the username that is logged in right now to Jenkins. So we got that. It's great. It's awesome, but we are, as hackers, we always want more. So how can we get more? Well, usually login mechanisms use a query parameter to redirect users to a different page after a successful login. Luckily for us, Jenkins has the same mechanism. So let's try doing the same thing, but using the from parameter in Jenkins. And let's point it to a job inside of Jenkins. Let's say it's first build right here. And we want to get its console log output. So basically, we want to get a console log output of the build itself. I'll just remind you that sometimes those console output of builds might contain secrets that aren't correctly masked. They might contain internal addresses of companies. They might contain internal tools used by companies. So it could help us broaden the attack surface of our target in order to better exploit their systems. So what happens next is the same as before. We get a redirection with a cookie, and GitLab follows the redirection, and we get back the console output log of the job we wanted. Great success. Let's see how it looks like. You can see here in a text form the response from Jenkins. This is, again, the page on GitLab. We can see here a token that is used inside the request, and it's not masked, so we can see it inside. And this actually works. One more thing worth mentioning is that because GitLab follows the redirection, what we can do, we can basically set up our own server, and we can send webhooks to our own server, and we can make that server redirect GitLab to do whatever GET request we want. So we can do any GET request to any endpoint in the world coming out of GitLab's IP address range, and we can maybe do more fun stuff with it. So let's sum up this part. So if there's no authentication to Jenkins, we can basically access any internal page that we want. If there is an authentication, we can brute force the user's credentials, then access any internal page we want using the from parameter with the redirection. On the first one, we don't need it. But as I said before, we as hackers always want more. What else can we do? So what about non-vulnerabilities?
Okay, so by now we showed how we can try and abuse some of the different Jenkins endpoints to try and retrieve data and make some actions in the system. And to do that, there are some preconditions that need to be met. We should be able to brute force and get users' credentials. Sometimes we need to be able to send HTTP GET request, which is not trivial, and some other conditions. But there's another very interesting path that we can try, which is exploiting known vulnerabilities in the CI. Now, any system suffers from known vulnerabilities, Jenkins as well. What if we could send exploits through the Webhook service and execute them in the internal CI? For example, we can send this. Pretty straightforward, right? Yeah, you probably scratch your head. I get you. That's an exploit created by Orange Sai a few years ago, which grants us unauthenticated remote code execution on Jenkins instances, vulnerable instances, simply by sending one GET request, and you can achieve a reverse shell at the same moment. It makes Jenkins download a malicious jar file that will allow us execute commands on the server. I won't get into details because that's not the topic of what we discuss here today, but you need to know that we can use it, and let's see what happens if we send this payload over a demo. What happens if we send this payload towards a vulnerable Jenkins instance located behind the firewall. So there it is. On the right, you can see two terminals owned by the attacker. Once we send the payload towards Jenkins, Jenkins will download the malicious jar file I just mentioned. It will be served from the upper terminal on the right. And immediately after that, we will achieve our reverse shell that you will see in the bottom right terminal. Now on the left, that's the attacker's browser. You can see that if we try to directly access the Jenkins instance, it won't work because it's not accessible to the world. It's only accessible to the IP range of the GitLab Webhook service. This is how this Jenkins instance was configured. So we create a webhook with a payload. Since we need to send a GET request, we use our own service that will handle this redirection. So we will be able to send a GET request and not a POST request. And once we trigger this, you can see that the malicious jar file is served. And on the bottom right, you can see our reverse shell right there, like 1 second after we send the webhook, and we can just execute commands on the Jenkins server, view its files, run whatever we want. So that's awesome, because before that, we were pretty limited with the opportunities that we have to attack the CI, but now you can see that by sending one single request from a foreign GitLab organization towards the internal Jenkins position behind the corporate firewall, it's not accessible to the internet, right? We immediately got a reverse shell, and we can freely execute commands on the Jenkins server.
Okay, so up until now, we've seen how we can exploit a single Jenkins instance. But the next thing we wanted to do in our research is to see how can we access internal Jenkins instances at scale. So we did a little bit of scripting, and we came up with a methodology to do it, and let's go through it. So first thing we did is we've subscribed to a passive DNS service that allowed us to query their database for DNS for domains, and we queried it for domains that contain the name Jenkins. We got back 3.6 million domains. They have much more domains that contain the name Jenkins, but we started with this data set, and we started analyzing it. So first thing we did is we wanted to make sure that the domains actually resolve to an IP address, so we sent DNS requests to all of them, and we filtered out all the ones that don't respond. After that, we wanted to get all the domains that have internet access. All the domains that have internet access are not relevant for us because we're looking for domains that are not accessible from the internet. So we've sent HTTP requests to all of those domains. All the domains that had internet access, we filtered them out. And we were left with 800,000 potential Jenkins domains that are potentially accessible from GitLab. So the next thing we wanted to do is we wanted to know which of those domains are actually accessible from GitLab. So we wrote a small script. What it does basically sends 800,000 webhooks from GitLab. It didn't take too long to send all of those requests, about a day and a half. It took much longer to write the script itself. But we sent those requests, and we were left with domains that responded to GitLab. So now we have domains that responded to GitLab, and we want to know which of those domains are actually Jenkins domains. So what we did is the webhook request we've sent to those domains is a special request that returns a special response from Jenkins. So we can easily identify which of those domains are actually Jenkins instances. And the script also went through all of the results. It scraped the GitLab UI to get the HTML that we got back from the requests. And what we're left with is we were left with 115 Jenkins domains that are accessible from GitLab. They are not accessible from the internet. And the next thing we can do with them is the same as we've shown you before. We can exploit those Jenkins instances anonymously through GitLab. Those domains might be domains of organizations, companies, open source projects, we don't know. We didn't attack them. We just know we can potentially attack them because we found they are accessible from GitLab. So this is amazing, this is awesome. But what about other platforms? So we didn't look on other platforms, but this attack is theoretically possible on more systems like artifact repositories, other CI systems, other source code management systems, and so on. But we have a few examples for you that we did check. So let's start with the Azure DevOps. Azure DevOps uses the same IP range, the source IP range, for all of its services. So Webhooks and Azure pipelines requests are sent from the same IP range. So what we can do, basically, let's say there's some kind of Azure DevOps organization that is connected to Jenkins, and we want to attack that Jenkins. We can create our own organization. We can create an Azure pipeline. We can write there any code that we want, send it towards the Jenkins. Basically, we can do whatever we want. Super easy. And last example, let's talk about Bitbucket. So Bitbucket has the same configuration. It uses the same source IP range for its Webhook service and the Bitbucket pipeline service, so we can create a different organization and basically attack those same Jenkins instances.
Okay, we want to thank Yaron Avital, Daniel Krivelevich, and Tyler Welton for their great contribution to this research. We highly appreciate your help. And let's summarize. Let's talk about what you can do to make sure that your environments in the organizations that you work for are protected against this attack method. So if you want an hermetic solution to this attack method, you can simply stop receiving webhooks from SaaS-based SCM towards your internal CI. But it could be replaced by periodically polling the changes by the CI or to implement a proxy between the SCM and the CI. But both of these solutions might be a bit expensive to implement or not to meet the engineering needs. So if you wish to keep receiving webhooks directly from the SCM, there are some countermeasures that you can follow. You can only allow inbound traffic to reach the CI and not any additional internal service, and if possible, only allow it to reach specific endpoints in the CI. Second, we recommend to implement a secure authentication mechanism in the CI, which provides security controls that meet the industry best practices. For example, you can integrate the corporate's SSO with Jenkins, so it will require strong passwords, it will protect you against brute force attacks, all of the stuff that we just, some of the stuff that we presented here. We always recommend to update the CI system and its installed plugins to the latest available versions. Disable anonymous access in the CI. Any data that is retrieved from the CI or any action made in the CI, this should only be allowed after a successful authentication was made by the user against the CI. And ensure that there's an audit log in the target system in the CI, which is enabled, and all the relevant logs are sent to your SIEM or alternative login aggregation solution, so you will be able to identify malicious actions happening in your CI. So that's it for today. If you have any questions, you are welcome to come over after the talk, and thanks for joining. Enjoy the day.
You can also approach the mics if you want to ask any questions. We have some time. If anyone, yeah.
Okay,
hello.
Thanks a lot.
Hey.
Oh yeah, sorry.
Hey, so I like how you were using different repos to try to attack Jenkins, but were you trying to attack any other pipelines other than Jenkins?
So this is a part that Asi mentioned. We didn't really try to use it against other CI systems, vendors, but we are pretty sure that the same behavior exists in all or most of the systems. It could be CI, it could be artifact registries, any internal system which can receive these webhooks because they act the same. You have login endpoint, you can retrieve data, you can make an actual system, all using HTTP, so it should work, yes.
Okay. And I'll just ask. Oh, did you? Oh. Did you report this to Jenkins so that they, like, is this a new novel approach? Are they aware?
So that's a good question. We don't consider this behavior, not for Jenkins and not for GitHub or GitLab, as vulnerabilities, because it's a way to abuse the way that these systems work, but it's not that these systems work insecurely. I mean, if you and us do the right job, like protecting the login mechanism for Jenkins, for example, or limiting the network towards the Jenkins instance, this should work. Same for what you can do, things you can do in GitHub and GitLab. So there are some countermeasures that you can take into place, but I don't consider it as a vulnerability. We could have, for example, let them know of the behavior that we showed, that you can access the login endpoint in the query parameters, but that's already solved. So there's nothing to report there.
Yeah, one more thing I'd like to add is that we thought about reporting to GitLab about the issue that they're following GET requests, but we've seen an issue that someone opened, I think 2 years ago, about this thing, and GitLab said that the following the redirections is okay, and they're not going to change it. So, yeah.
Yes, I do have a question about GitLab runners and GitHub actions. Sorry. Yeah. So, is there a reason why I can't just use that rather than webhooks instead? Wouldn't it be easier to just run it on a runner? If the runner already has access to internal CI/CD systems, I can run a cold call and.
Yeah, because the source IP ranges for the Webhook service and the runners is a different source IP range, so you won't be able to access the CI system.
Oh, so only the IP range for the webhooks are able to access the CI/CD systems and not the runner systems.
This depends on the configuration that any organization set in their firewall. But usually they only configure access to the Webhook service.
Got it.
Yeah. If they have access to anything, to also the runner's IP address, you can do anything you want. But yeah.
Yeah, that's what happens in Azure and in Bitbucket. There you don't need all these complex methods that we showed. You can, if a company wanted to only whitelist Webhook requests from their Azure repos or from Bitbucket repos, you can create your own pipeline and access it because they share the same IP range anyway, so you can't avoid it. So that's a bigger problem in Azure and Bitbucket. In GitHub and GitLab, if you only whitelisted the Webhook service, so you should be in a better position than if you would whitelist the IP range of the GitHub Actions pipelines as well, the IP range of that.
Cool, thanks.
Yeah, sure.
For that demo you showed earlier where you established the reverse shell, did you have to authenticate? Or, so that one,
no.
What's the protection mechanism for that then?
No, it's, that exploit uses, you're able to exploit the Jenkins without authentication. It's an unauthenticated remote code execution exploit. Only thing you can do is update your Jenkins or limit network access. Yeah.
Okay, so newer versions of Jenkins are protected from
Yeah, this exploit is from 2019, but still we see a lot of Jenkins instances using old versions. So
I see.
yeah.
Thanks.
Okay.
Any other questions? Okay, we are also here for questions, and thank you very much for joining.
Thank you.